Hello everyone. Today we'll be starting the second part of the geometrical properties of this section, that is the third unit of strength of materials. Okay, in the last class we have studied the basic definitions of the geometrical properties. Okay, then we studied what is moment of inertia and centroid. Okay, and the formulas to calculate the centroid or the CG. Then we found out the um, what is polar moment of inertia, what is radius of gyration. Okay, then now we'll find out the some um, fixed formulas for the regular shaped objects. Okay, the moment of inertia formulas is given along its uh, centroid. Okay, so the first one is for the rectangle. Okay, it is along the x-axis. Okay, along the x-axis the formula is this BD P plus into d cube by 12. If it is along the y-axis, then it is db cube by this db cube by 12. Okay, if it is y-axis. Next is for triangular, it is bh cube by 36. Okay, from the vertex. From the vertex, if you are calculating. If you are calculating from the base, then it is b cube bh cube by 12. These are the formulas you have to keep into while solving the problems. You have to know these formulas perfectly. Okay. Next is for circular, it is pi d raised to 4 by 64. Pi d raised to 4 by 64. And for the hollow rectangular shape, it is bd cube by 12 minus the inner dimension, that is smaller dimension, that is bd cube by 12 for ixx. For iyy it is db cube by 12. The formula remains the same, but we have to divide by the greater external area moment of inertia by inner moment of inertia, so that we can get the moment of inertia of this hatched portion, right? If this is your outer section, okay, and this is your inner section, if you minus the outer section from the inner section, you will get the remaining hatched portion of the sections. So that is what it is done by minusing the greater by smaller one. Okay, next is the hollow section of circular. So in case of circular, it is pi d pi 64 into d raised to 4 for solid one. In case of hollow, it is d raised to 4 minus d raised to 4 in bracket, right? This capital D is the outer diameter and the smaller d is inner diameter. Okay, next is we'll try to find out or understand how to calculate the center of gravity of any object given to you. Okay, if there is an object, okay, there is an object and this is your x and y and x axis. Okay, now we want to find its exact centroidal distance of the object. So what we have to do is, here in this case it is only one object, so it is very easy, that is it is rectangle, so d by 2, right? Because it is a regular shape, so we know the formulas as I have told in the first slide, right? Because it is a one shape object, so it is very easy to find out, and it is a regular one. If it is a built up section like this, okay, and it is connected here like this, like a T, okay. So where the this is your A1 and this is your A2, right? Where this body is one, but they are two different parts. Same way, whenever we get such build up sections, we have to divide the whole body into two or three parts depending upon the number of parts you can form. In the eye section, you can make three parts, right? 1, 2 and 3. In T or L sections, it is 1 and 2, right? So that time you have to use the same formula here. We don't know where will be the center of gravity, right? We'll keep a approximately line here, okay? We don't know exactly where, okay. Now we have to find out a reference line. We'll consider the reference line is here, okay, x and y, okay. So now this is your section, first section, and this is your second section, okay. Now calculate the area of the first section, that is A1. Then find out this is your x-axis and this is your y-axis. This is a reference line. This is, you can change the name of it. This is A and this is B, okay. On this reference line you have to find out those draw it once more. Okay, this is your reference line AB and this is your axis, y-axis, and this is your horizontal axis, that is x-axis. So we'll divide the whole body into two parts. This is your first and this is your second body. So we'll calculate the area of the first figure, that is this section, so A1, okay. Then we'll find out the what, x distance. This is your y bar, it is your final answer, okay. And this is what your x bar final will get to this centroid of gravity, x bar and y bar. So to calculate x bar and y bar, we have to calculate x1 and y1, okay. Here there are two, so we have to find out x1 and x2, because we will find x1 for this object and x2 for this object. So how to calculate the x1? So what you have to do is you have to calculate this x distance from the half of the uh, distance of the that body. If suppose if you want to calculate x1, what is the total length of this first body divided by 2? If it is L1, then L1 by 2 will give you x1. Okay, then in case of this second body x2, it will be here it is width, so w1 by 2. Okay, it is not I am not able to draw it properly, but when we will start solving the problems I will explain once again. Okay, but this is your formula to be kept in mind for x bar and y bar. This x bar and y bar are nothing but from the reference lines. Okay, you will find x bar in this direction because this is your x direction, x axis, and this is your y bar because this is your y axis. So when they meet at a point, that point will give you the centroidal point. And next is how to calculate the moment of inertia. Okay, to start with the calculation of moment of inertia, first we have to calculate the center of gravity by the previous method. Okay, by the using same formulas you have to calculate the moment of inertia of, first calculate the center of gravity of that body, then you have to calculate the moment of inertia of the different single bodies. Okay, you have to calculate the uh, moment of inertia of separate designated bodies. In this case, if this is 1 and this 2, then you have to calculate the Ig1 and Ig2 separately. Okay, and Igy and Igy2. Okay, about the x-axis and the y-axis of the first section, and about the x and the y-axis about the second section. So you have to calculate the moment of inertia of those, okay, those objects. Next, using the parallel axis theorem, you have to find out the ixx and iyy, okay, with a from the reference line. So what is your reference line, where it is, we will be understanding in the problems we are going to solve. Okay, you have to keep in the mind this formula. It is same as the above formula which we have studied. IAB is equal to Ig plus A into h square, where h square is nothing but y bar, that is the center of gravity that you have calculated, minus the half the distance of the body or the object, the whole square. Okay, next is the area. Okay, if it is A1 the area of the first object, and y1 is nothing but with reference to the reference line, calculate the half the distance of the that object from that reference line. If this is 10, means 10 by 2, that is 5 plus this height, so total height will become be 5 plus the remaining height at the bottom for to the reference, that length will be your y1. Okay, we'll try to find out how to solve this.